finding unknown factors. So for a while now, as sixth graders, you've been solving problems with unknown factors. In this lesson, we'll solve problems in which the unknown factor is a mixed number or a decimal. So just a little extension of what you already know. Remember that we can find an unknown factor by dividing the product by the known factor. So let's look at this first example. We have a multiplication problem here. 5n equals 21. In this multiplication problem, the product is 21, and our two factors are 5 and n. In fact, you could look at this problem, rewrite it like this to see clearly that there are two factors, 5 and n, that equal the product 21. So we can find this unknown factor, n, by dividing the product 21 by the known factor 5. Let's rewrite this problem then as a division problem. And the reason we can do this is because division is the inverse or opposite operation of multiplication. So here's our dividend, 21. We're going to divide it by the known factor that now becomes our divisor. Simple problem you've been doing probably since 4th grade. All right, we do have a remainder, and since there are no decimals in this problem, we're going to write the remainder as a fraction. So our answer is 4 1/5. So if we come back to our original problem, n equals 4 1/5. Let's look at our second example. 0.6m equals 0.048. Remember, when a number and a letter are side by side, it means that we're multiplying. And remember that to find the missing factor, in this case m, we use the inverse or opposite operation, which is division. So this is a multiplication problem. We're going to use division to find the missing factor. When we write the division problem, the product becomes the dividend. So let's write our problem. Here's the dividend. And then the known factor becomes our divisor. And the missing factor is what's going to be the quotient. So it would go up here in our problem. But I'm going to go ahead and erase that so we can work our problem. Now when we divide decimals, it's common to move the decimal in the divisor to create a whole number. We'll move the decimal over one time in the divisor, and so we must do this also in the dividend. Move it over one time, and we'll go ahead and put it up here. So over, over, up. Just a note that it's okay for the dividend not to be a whole number. We want the divisor to be a whole number, but the dividend can still have decimal places. So now we have a simple division problem, 48 divided by 6, and we know the answer is 8. But what about this space here, right in here? The answer is not 8 tenths, it's 8 hundredths. Therefore, we need to use our 0 placeholder. And let's just check ourselves by doing the multiplication problem, the inverse operation. So 6 times 8 is 48. And then we're going to count our decimal places. 1, 2, 3, 1, 2. Ooh, we need that 0. 1, 2, 3. So look, have proven that it's 8/100ths, not 8/10ths. So then coming back to our original problem, we can see that m equals 0.08. Our final example, this problem looks like it seems backwards because the multiplication is on the right side and the answer is on the left side. However, an equal sign is not directional. It simply states that the quantities on both sides, on either side of the sign, are equal. In this case, the product is 45 and the known factor is 4. So we could reverse the problem and it still means exactly the same thing. So again, this is a multiplication problem. To find the unknown factor, we need to create a division problem. So the product becomes the dividend, the known factor becomes the divisor, and the quotient, the answer to this division problem, is what is our unknown factor. So then again, it becomes a very simple division problem. 4 goes into 4 once. We subtract, bring down. 4 goes into 5 once. We subtract and we find we have a remainder. Since there are no decimals in this problem, we'll go ahead and write it as a mixed number. And coming back to our original problem, we can now say that x equals 11 1/4.